Imagine you're building a game with millions of users, and latency spikes suddenly occur. I discovered that CPU cache misses are the primary culprit. But did you know that some CPUs have an invisible cache hierarchy that can be exploited to reduce misses? I dug into the actual architecture of these CPUs and found a treasure trove of microarchitecture tricks. It turns out that some CPUs have cache aliasing that allows them to remap cache lines to reduce conflicts. This is a well-guarded secret, but trust me, it's game-changing. One such trick is cache line partitioning. Essentially, the CPU divides each cache line into two or more smaller segments, reducing conflict and increasing hit rates. This technique requires extremely low latency memory, but with the right setup, it can yield 10x improvements. But here's the interesting part: not all CPUs are created equal. Some architectures have built-in support for cache line partitioning, while others don't. This means that even if you implement this technique, it might not work across all platforms. This highlights the importance of microarchitecture review when optimizing CPU-bound tasks. Simply relying on cache-friendly data structures is not enough. You need to understand the specific CPU design to maximize performance. Another lesser-known cache trick is cache prefetching. When the CPU anticipates memory access patterns, it can prefetch data into the cache before it's actually needed. This reduces latency and improves system performance, but it's only effective with predictable usage patterns. Cache prefactoring also raises an interesting point. CPUs have varying prefetching units that manage this process. Some architectures dedicate more resources to prefactoring than others, making this technique even more platform-dependent. To optimize cache prefactaching, developers can use specialized compiler directives, like fnostor-mem, to let the compiler optimize for better cache performance. This can yield an additional 5 to 10% boost in performance. Lastly, keep in mind that subtle modifications to your application's memory access patterns can significantly impact CPU performance. Without this knowledge, many developers end up wasting time and resources fine-tuning algorithms that perform poorly on specific CPUs. In conclusion, mastering CPU microarchitecture is crucial for top-tier performance. By utilizing cache partitioning, prefactoring, and other secrets, developers can reclaim lost milliseconds, bringing a competitive edge to the table. Like and subscribe for more in-depth tech tutorials.